Hey everyone, it's that Math Magician, and on this video, I want to talk about problem 109, which is really just an extension from problem 108. So to recap from 108, a 4-digit number that had the numbers between 1 through 7 included, and we were allowing those numbers to repeat. Okay, so that meant that each digit here had 7 different possible choices, right? I'm pulling from the numbers 1 through 7, so each digit had the numbers 1 through 7 on it. Now for 109, it says, how many 4-digit numbers could you make? So we're still dealing with a 4-digit number. And it says with the digits 1 through 7. So this hasn't changed. Numbers 1 through 7. And if you could not use any digit more than once. So that means that we are going to have without repeating. What that means is if I make a 4-digit number, let's say I had the number 1, 2, 3, 4, that number would be fine. There's 4 digits. Each digit is a number between 1 through 7, and none of my digits repeat. But if I were to erase this 4 and instead have written this number, 1, 2, 3, 3, this number would not fit for problem 109 because I have a 3 repeating. We don't want any digits to repeat. So it asks you, how many possible numbers can you make that fit these guidelines? We're going to want to create another decision chart. So go ahead and draw out your 4-digit slots. This is my first digit, my second digit, my third digit, and my 4th digit. And here's where things are going to change a bit. Okay? In my first digit here, I can choose from the numbers between 1 through 7. So how many digits will I be able to choose from? That answer is 7 different decisions, 7 different numbers. So I'm going to write a 7 here again, just like I wrote that 7 up there, because there are 7 different numbers to choose from. Now, when I move to the second digit, I no longer have 7 numbers to choose from. And what may help is if I write those 7 numbers out. 1, 2, 3, 4, 5, 6, 7. Those are all of the numbers I can choose for this first number. Now, once I choose one of the numbers, I'm unable to choose it again. So that means whatever number I choose, let's say I chose a 3, I'm no longer able to use a 3. So when I get to the second digit, I only have 1, 2, 3, 4, 5, 6 numbers to choose from, because I've taken one of the numbers out of the pool of numbers to choose from. Okay? And this same thing is going to happen when I move to the third digit. Let's say for the second number I had chosen, number 5. I can no longer choose a 5, and I still can't choose a 3 again. So that means for my third digit here, I only have 1, 2, 3, 4, 5 numbers to choose from. And hopefully we can see that with the 4th digit, I'm only going to have 4 digits to choose from. These numbers keep going down by 1 because I'm not allowing repeating. Every time I choose a number, I take that number out of the pool of numbers to choose from. And so my digit choices get lower by 1 each time. And just like we did up here with our decision chart on 108, I'm going to take these 4 numbers, I'm going to multiply them. So you need to go into your calculator and do 7 times 6 times 5 times 4. And that ends up being 840 different numbers to choose from. So I want you to recognize that when I allow repeating to happen, when I don't care about which number comes up and if it repeats, we end up with over 2,400 different numbers to choose from, right? Those are all the possible outcomes we can get from those numbers. But once I say, no, we're not going to allow repeating to happen, then I end up cutting that number. It's like 3 times as less than the number of options that I got when I did allow repeating. And that's the crazy part of how just a simple word in a sentence that said with repeating and without repeating can totally change our answer. So I hope this worked as a great introduction for you guys for this assignment. And if you guys need any more videos for any other problems, go ahead and either email me, comment on this video, comment in our Google Classroom, and I will get those up for you. All right, guys. See you guys next time.